Record. All right, we're live. So hello everybody, welcome to another ONOS or micro ONOS TST meeting. This is a public and recorded meeting. And today we have a couple of items on the agenda. First of all, it's to talk about the certificate proposal from Deep. Then it's to talk about also a brief update on the distributed stores that we have in ONOS config. And also on, I believe there was also item about documentation, or was that for next time? I could be getting mixed up here. And also we want to provide a brief update on Basel 1.0, mostly just a reminder. So with that, I'm going to pass the buck here to Jordan, Sean, and Andrea to provide the update on distributed stores.
Sure. Thanks, Tom. Yeah, I just included the docs and the Basel 1.0 in the agenda. So in the past week or so, we did an effort to include, thanks to the great work from Jordan, to do the distributed stores from backing of the distributed store done in Atomics for devices, network configuration, and device changes. So the infrastructure is in place for it to be used by ONOS config, meaning that there are the different classes that Jordan will talk about. Everything is merged. It's already being used in the device store, meaning that the device store is already updated to the most up-to-date version, and we also removed a few middle events that were done to integrate with previous versions, so it's a linear implementation. And we're currently in progress of moving the network store and the change store to the new implementations that Jordan will talk about. At the moment, today, we just got successfully implemented a patch that allows us to, in parallel, write to both the in-memory store that we had until now and the Atomic store. We decided to go in parallel between the two, so to keep the two implementation, because that would allow us to have a cleaner swap between the two. And the set of steps that is gonna happen is the following. Basically, we're gonna have the two stores side by side, and that's already merged. We're gonna have it writing and reading from both. And the admin and the ags were changed by Sean today to accommodate those reads from the new stores. And then we're going to move the tests to the new stores, expecting the same exact results through the mocks that we have done and we have merged of the stores. And then at the end, we're going to move the functionality to the stores and make sure that the integration test passes.
Quick.
That's kind of the steps that we're going to do.
Andrea, quick.
So, yes.
Did you mean, is there slides for this, or because we're just seeing distributed?
No, I didn't have any slides for this.
I just want to make sure that in the case we were advancing, we didn't miss it. Never mind. Thank you.
No. I just was just giving a brief update on and an overview of how we're going to do things. So first in parallel, then we're going to move the stores for the tests, and then we're going to use them in the functionality code from the northbound, making sure that the integration tests actually happen. So with that, I think Jordan has an idea. I wants to give an overview of what we did in terms of Atomic support. So with that, I'll leave it up to you, Jordan.
Okay, thanks. Let's see. Okay, yeah. So basically, the goal for this work was to support multi-node clusters, tolerate failures, and still maintain consistency in the face of failures. Ensure that changes that are in progress during failures and things like that get to proceed after failures and work towards the scalability numbers that we were seeking. So in doing this, I kind of rethought a little bit of the data model. So basically, there were 3 stores in ONOS config previously. Now there are 2. So basically, one of the types that was added is network change. So a network change is basically like a GNMI request from the northbound. So it's a multi-device configuration change. And the types also have some information about lifecycle, which I'll talk about. And these are protobuf. These are protobuf files, and the reason that they're protobuf files is because these are objects that need to be stored and sent to other nodes and things like that. And then there's a device change, which is basically a change to a single device. And it looks pretty similar to the network change, aside from the fact that it's just for a single device. And so to store those types of objects, there are a couple new stores. So the network change store and the device change store. The network change store is an append-only log of changes. It guarantees total ordering of changes even after failures and things like that. It provides monotonically increasing wall clock timestamps. So basically, it provides times that are guaranteed to be consistent across nodes, regardless of even if their clocks are out of sync or something like that. And then since it's ordered, it allows us to replay changes, modify specific changes and things like that. And so the device change store is pretty similar to the network change store, except that it has a per device log of changes. So each device has its own log, and aside from that, it looks very similar to the network change store in terms of how it's stored. So this diagram sort of shows what the stores look like. So the network change store is basically a complete history of all the changes. And then from the network change store, individual device changes from each network change are propagated to the device change store. And there's a per device log in the device change store, basically indicating the order of changes in each device. In addition to that, there's a new leadership store and mastership store. So the leadership store basically provides leader election for the entire cluster, so it can guarantee a single leader. And then a mastership store, which we're familiar with, which basically elects a leader for each device. And I'll talk about how these are used in a minute. So those are the stores, but in addition to the stores, I wanted to rethink sort of how events are handled and how information is propagated, how failures are tolerated. And so we introduced this new abstraction called controller. So controllers are basically like a replacement, in part for a replacement for event listeners. Basically, they sort of coordinate state changes for the cluster. So states, and listen for events. So they react to network changes, manage the life cycle of network changes and device changes, modify them, and decide how things happen and what happens. And these are the controller abstraction is modeled on Kubernetes controllers. So this is a really fundamental concept in Kubernetes. When you interact with the Kubernetes API, all you do is create an object, and Kubernetes basically asynchronously works to get towards whatever goal you gave it. So if you create a deployment and say, I want a deployment of 3 pods, it's controllers inside Kubernetes that work towards deploying the pods on the correct nodes, ensuring that there are always however many number of pods you want running, things like that. And that's a control loop that does that inside Kubernetes. And so the controller abstraction provides for a lot of the complexity that we had to previously implement ourselves. So it basically provides generalized failure handling. So it handles exponential backoff and retries and things like that. It handles recovering lost events after failure. So this is one of the things in classic ONOS that was really done poorly with the model that we were using, which was after failures or during failures, it was almost never, well, missing events were almost never accounted for. And so it was pretty easy to get the cluster to misbehave by things like network partitions and things like that. And then the controller abstraction provides cluster coordination, so it can do leadership election, mastership election, distribute events to the correct nodes, for example, device masters. And then it also abstracts away concurrency control, so it can, within each node, it can create separate go routines per device with that, or in the case of the device change. And so the controller is sort of like an abstraction for running what are called reconcilers, and this is also taken from Kubernetes. So basically, the reconciler is the component of a controller that is actually run to handle some specific type of object. So in ONOS config, there's a network change reconciler and a device change reconciler. Basically, this just gives code that says when some object is updated, this is what I want to do with it based on the state. And the cool thing about how these are written is that they don't depend on order, which significantly simplifies failure recovery. In classic ONOS, we depended really heavily on events being delivered in a specific order, because then we could make assumptions as far as relationships between events. If A happened before B, then B happened after A, whatever. And so reconcilers can be triggered to be, or can be configured to be triggered on specific events. So like the network change reconciler is triggered on network change events and reacts to network change changes. Some of them are configured to react to devices connecting or disconnecting, etc. And basically, the code of a reconciler is given some object ID, a network change ID, or device change ID, reads the current state of the object, the network change or device change, and then modifies the store to reach the desired state. And this is like a phrase that you see a lot in Kubernetes documentation, the desired state. Kubernetes always works towards the desired state. I'll talk about what the implementation actually looks like. And then the controller calls the reconciler in the loop. So if the reconciler fails to get to its desired state, the controller will recall it, wait for more events to happen, recall it. If a failure happens, it can just be called again on another node, and that constitutes recovering from failure. And the reconciler code doesn't have to do anything to handle failures. It's just built into the abstraction. So there are a couple of controllers that are added to handle these new objects. So the network change controller, basically it's a single instance controller. So it uses leader election in a multi-node cluster, ensure that there's only one node listening for changes to network changes and reacting to them. So when a network change is created in the store, it creates device changes that will modify the individual devices, and then the network change controller is responsible for ensuring that things happen in a specific order. So basically, the network change controller waits until the previous network change is done being applied, and then it says, okay, we can apply this network change. So it notifies the device changes that they can be changed, and then they'll eventually be applied by the device change controller, which will show. It has some logic to parallelize changes to non-overlapping sets of devices. So it allows it, since it has a global view of the network, it can allow some concurrency where it's safe. And then for each network change, it monitors the results of the device changes, which potentially happen on other nodes. And determines when a network change is complete and updates the clients and back information. And then the device change controller listens for the device changes that were created by the network change controller. And for for each device change, which will be associated with a specific device, runs on the device master, applies the change when the change is supposed to be applied, or when the other controller says the change can be applied and it's safe to be applied, rolls back changes when they need to be rolled back, and updates the device changes with results from the southbound, which will be propagated back up to the northbound. And so this is sort of a diagram of what that looks like. So at the top, there's the northbound API. When a stat comes from the northbound, it goes into the network change store. The network change controller sees the new network change, propagates it to the device change store. The device change store events trigger device change controllers for potentially on different nodes for different devices, which are the masters. They monitor the device change to determine when it's safe to apply the change, push it down to the device, and then it gets propagated all the way back up to the network change controller, to the network change store, and so because these components are interacting through stores, it's fault tolerance is just built into the abstraction. You can kill, you could kill any node at any point when handling any network change or any device change, and it will very easily recover from failure because of the way that the code is designed, where data is being stored. And so, but one problem also was, if you go back to the diagram of the stores, these are just a bunch of append-only logs that are unbounded, and so that means at the rates at which we want to basically support changes, these stores will eventually fill up, and not in all that much of time. And so I also wanted to build support for preventing the stores from just filling up infinitely. And so that introduced another type of object, which is a snapshot. And so the goal of a snapshot is just to reclaim storage space without losing important information. And it does that by basically rolling up portions of the change history into a single change and persisting it, but while also retaining whatever history the user wants to retain for review and rollbacks. And so the process of snapshotting the stores is basically this is also implemented through controllers. So there's a network snapshot controller and a device snapshot controller. The network snapshot controller basically iterates through the network change store and figures out which changes meet the snapshots criteria and this can be removed, and then notifies device snapshot controllers, and the device snapshot controller basically replays the history of changes that meet the snapshot criteria, rolls up the changes into a single sort of big change, stores it in a snapshot, and then that allows the changes to be discarded. And so once, I'll show some diagrams actually. So for example, this is like a device change log, like the one that I showed on the first graphic. So the device change has all these changes. So the changes in green are basically changes that have been applied. Changes in gray are changes that are still in queued and are in the process of being applied. So say you want to, say this isn't 20 boxes long, but 20 million boxes long. You want to get rid of some of those, and say you can tell the system, I want to take a snapshot, but make sure that we keep the changes from the last 24 hours. So the network snapshot controller tells the device change controller that this is where 24 hours ago happened. So basically, it's safe to get rid of all the changes prior to that, but you want to keep all the changes after that in case the user wants to do rollbacks or wants to look at what happened in the last 24 hours or whatever. And so the device snapshot controller basically replays the changes that are now in yellow, rolls them up into one change, and then replaces that with a snapshot. And the snapshot is much, much smaller than the 10 million changes that were rolled up with the snapshot, because there are lots of duplicate changes that actually operate on the same path. And then you don't lose any of the state, so redetermining the state of the the device is just a matter of taking the snapshot and replaying the additional changes in green. You don't lose any information, but you conserve a lot of space. So that's all the source. That's all I have, I think. Yeah.
This is excellent, Jordan. Do you see, I mean, I do, but I just wanted to confirm with you, this would easily translate, let's say, for example, to dealing with flows, meters, and groups, things like that with, that we interact with the devices using before runtime?
Yeah, so I think it translates to a lot of places. So one issue with the pattern, the controller pattern, is that it depends. I mean, the reason that it's fault tolerant, and the interesting thing is I've seen a lot of Kubernetes developers saying that this pattern basically has hid bugs because it basically the system recovers from problems just by the fact that the way it works is that all it cares about is the current state of the system and the state of the state that it wants to get to. It doesn't depend on a lot on reliability. Like you can just retry and retry and retry and retry, and it doesn't matter what order things happen in. All it looks at is the current state of some store, and with the current state of some store, what it wants to do with that state. But there's a cost to that, which is querying the current state of some object is costly. And so Kubernetes relies really heavily on caching for that reason, which if caching, if you can successfully cache things that query frequency is not a big issue. So I just think it depends on if you can overcome the issue of potential performance issues from querying stores. I mean, if you can cache, as long as you can reliably cache objects that would need to be accessing for things, it's definitely accessible elsewhere. I think it's a great pattern, but this will be a good experiment.
Right. Well, great. Thank you very much, Jordan.
Yep.
So I guess with that, we can probably move to the GUI part, which will be Sean, I take it.
Yeah. Okay, so there's just I took Jordan's ideas from that he explained just there, and I just tried to sketch them down on a one-page view. So if you just go to the next slide, Thomas, please.
Actually, Jordan, I'll let Jordan do that.
Okay. So basically, I just laid it out in a sort of just a slide to get people's ideas on how it might work. So rather than any kind of graphical view or sort of force graph view, I think it's suitable to put into a tabular kind of view here. And if you start at the bottom left, up along the left-hand vertical axis are the network changes applied sequentially in time. So basically, as you go through your day, you're making changes. Those changes apply to different devices that they're across the bottom, switch 1 to 5. And the blocks represent which devices have been touched by which network changes. At the bottom, I had a snapshot, which was the most recent compaction of config for each of those switches. And then, for example, like switch 4 was added after the last snapshot time. Switch 5 was added in a change after that. There's a few things you can do here. I mean, I think it will be easy enough to drive the state of these squares from the back end, the controller. So for instance, like, you might consider the top, the second one from the top there, it's got 2 network changes. One has been applied to the device, the other one is pending, so it's red. The network change above it is sitting there, it's pending, it can't be applied until the one below it has been applied, So it gives a kind of a visualization to the user of what the objects Jordan explained previously. I think an important feature, I think, would be to be able to sort the switches. So there on the bottom right of the screen, that sort of call out is saying that you know, if you were able to sort the switches, you know, you could, they're shown alphabetically at the moment, but, you know, maybe you could click a button to sort them by the number of changes. So you could see what the busiest switch is, and effectively you could have it could appear like a histogram of changes. You could see where the most changes were in your system. You could do it by change date. You could do it by device type and version. So you could group, you know, certain different types of device together and so on like this. And then I think through colors, you know, you can show again the real life status of the device, and again, you know, like we had in the previous incarnation for ONF Connect, we can be talking about configurations that are both connected to a real device or a device that hasn't even been created yet. And I think that's what switch 4 is. It's in gray because this device is offline effectively. So, you know, I think it's feasible to do. It's probably a view we can drive dynamically and give users a lot of insight into what's going on and a bit of interaction. And just to say that on the switch boxes at the bottom, by clicking on switch 1 there, for instance, that would bring you into the config view, which was the view that I showed at ONF Connect, you know, which had it spread out and displayed the tree of configuration and allowed you to switch on and off the history so that you could examine how it looked back in time. So, you know, I think it would bring together the previous work we've done on the subject as well. So that was really it. I don't know if anyone wants to leave me feedback. You know, if you want to address it now, or you can leave it on Slack or any other way at all too.
Well, this is
I think it's
really cool. Really interesting because, like you said, it does relate device and network changes nicely together in a way.
Cool. Okay. Okay, that was it for me.
All right. So,
oh, sorry. Sorry, I was just going to say what this is dependent on is an outbound interface that will expose the device store and the network changes store in a read-only fashion, and that's something I'm actually implementing at the moment. So it'll be available through CLI and will drive the GUI as well.
yeah, it's basically just an extension or augmentation of the admin interface, right?
That's it. Yeah, yeah. Okay, that's it for me.
Great. All right. So who did we have next? It was the certificates, correct?
Mm-hmm.
So Adi, do you wanna let me make you presenter?
Yes.
Here you go.
All right. Can you see my screen?
Yep.
All right, great. So regarding the certificate management, after Connect, I started to think about the certificate management subsystem. I played a little bit with the certificate management in Kubernetes. So in the context of ONOS, so the first question that we need to answer is that why do we need to have a certificate management subsystem? So there are two usages. First of all, we need to manage certificates for the communication between the subsystems inside the Kubernetes cluster. And also, we need to manage certificate on targets, for example, Stratum switches. Later on, when we support GNOI's certificate management service, so we need to provide certificates to this service that we can install, rotate the certificates on devices. So if you take a look at the GNOI specification for the certificate management, so there are two ways that we can provide certificates on targets. So the targets itself can provide the certificates to the client, and the client can install and rotate them on the devices. And also the clients can generate and sign the certificates and then install and rotate the certificates. So that means that In the client side, if we have a certificate management subsystem that we can use it for the inside Kubernetes cluster, we can also use it for generating the required certificates on the switch. So these are the two usage of the certificate management subsystem. So what are the design goals? The design goal is that, so an ideal solution would be a centralized certificate management subsystem that we can create certificates from the different certificate issuers, so that we can generate certificates for the local purposes and also for the production environments. We should be able to create certificates from different issuers, for example, Let's Encrypt. And we should automate creating certificate issuers, certificate resources, all of this stuff in the Kubernetes cluster. So these are the design goals. So we need a certificate subsystem for sure. So it should provide the capability to create and manage certificates and issuers and secrets in the Kubernetes. In Kubernetes, what we do currently, so we create a secret. The secret carry data about the certificates, and we create a volume that to provide access to those information, to those data for each of the subsystems. So that means that each subsystem can have access to the certificates, to this kind of information through the volume. Also, we also need to provide an API to the end users, and it should be a high-level API that we can create certificates, we can load the certificates for a service, and then revoke a certificate, all of these kind of operations. So if we ignore the switches, suppose that there are no switches, and we would like to manage certificates in a Kubernetes cluster, it's fairly straightforward. So there is a plugin and developed by a group, and it's also certified by the Kubernetes, called Cert Manager. So Cert Manager is, you can deploy it as a subsystem, like other subsystems in a Kubernetes cluster. So then it provides an API that you can create certificates, you can create issuers, and then associate a secret in a Kubernetes cluster with a secret. And what it does, automatically it updates the certificates when they want to be expired. So that's the only thing that it does. So managing the certificate. So when they want to be expired, to renew them. So I think we can use the same system. We don't need to develop a cert manager subsystem, but we can use this cert manager to develop a cert management subsystem to create certificates and create issues. So as I said before, GNOI also allows us to a client generate and sign certificates. So that means that in the client side, if we assume that we have a cert manager, we can generate and sign certificates for the target. So this is the architecture that I propose, but we can discuss it and see that if we meet our requirements. So we need a certificate subsystem, ONOS certs. So it provides a high-level API to the users, and it interacts with the Kubernetes Cert Manager. As I told you before, Cert Manager provides an API that we can use that API in ONOS Cert subsystem to create certificates, to create issuers, all of this stuff, and it supports different issuers. So, for example, it supports Let's Encrypt, it supports Vault, Venafi, and a bunch of other issues. So then Cert Management creates certificate, and then we also create secrets. So then we associate the certificate with secrets, and then these secrets are accessible in other subsystems, in ONOS config, in ONOS topo, and also in ONOS operation. So, and then we can use these certificates, and then we can use GNOI client to install and rotate the certificates on the Stratum devices. So that means that everything should be handled in Kubernetes cluster, and then we install a certificate on the devices. So this is the high-level architecture, but there are lots of details details that we need to think about. So these are the steps for the generating of a certificate using the cert manager. So first of all, we need to install cert manager in a Kubernetes cluster, and then we configure an issuer or a cluster issuer that we manage the certificate resources for a cluster. And then we create a certificate resource, and then we obtain a signed certificate. So if we need to obtain a signed certificate from a third party, so it communicates with the third party, and it obtains the certificate, and it maintains the certificate in the cluster. So, and also if we want to create a local certificate for the testing purposes, we can also do that. So something that we do now. So we already generated a set of certificates, so we have them and we use them in the subsystem for the testing purpose. So, and as I told you, we can use Cert Manager API in the ONOS certificate subsystem to create the certificate. So, but there are some open questions. So first of all, can we assume that we have GNOI on the target to install and rotate devices? If not, if we cannot assume that, how should we handle this? Probably we need to come up with an API that we can get the predefined certificate on a target and then manage that specific certificate. So another question that we need to answer is that for the production environment, if it's suppose that you want to provide a high-level API to the end user that they can create certificates, manage certificates, what are the high-level requirements for a production environment? So from the administrative point of view. So, and if we design this certificate subsystem, can we meet those requirements for the production environments or not? So these are the questions that we should answer, and I think I put these slides together to kick off this discussion. Any questions?
This is really good. I guess one comment on these two open questions is that I think with respect to devices that don't support GNOI, we should kind of revert to the approach that we're planning for GNMI and P4 runtime, which is require an adaptation layer. Now, of course, in the meaning that there will be a separate thing that will handle the translation, that between, let's say, GNOI and whatever else the device actually does support. And so in this case, we would be dealing with the adapter rather than with the device.
Also, there is another thing that we could do is that we could assume that if the device does not support GNOI, it could definitely support another way of managing certificates on it, or we could also provide an API, such as an add certificate, that provides an externally created certificate to the ONOS certs subsystem in such a way that you can go ahead and create it on the device however you want it and then provide it to us. Meaning that we would skip the installation phase of the certificate, but we could still use the certificate itself. Does that make sense?
No, yes, it does. Yeah, yeah.
The only concern about this is that because in Kubernetes, Cert Manager is responsible to create the certificate itself and maintain it. So if the target is supposed to provide the certificate to the client, right? So the question is that how can we manage the certificate? For example, when it expires, how do we know that the certificate is expired or that we can renew it? Because the target is already created a certificate, and the target knows that, okay, the certificate will be expired this time, or And the target should be responsible for managing of that certificate.
And again, this is the adaptation layer, right? So I think from Kubernetes standpoint, we should be, and GNOI standpoint, we should be able to manage the GNOI channel. And related channels, GNMIP for runtime, that required the certificates to be in place correctly. We can deal with that when dealing with a device that doesn't support GNOI, GNMIP for runtime. We would be effectively dealing with a proxy as an entity rather than a device. And then the proxy is then free to deal with the device however it wants to, because it then presumably knows what channels and what kind of ways of communicating it can use. And in that case, if it could use behind the proxy, it could use the approach that Andrea suggested. But I think right now we should stay focused primarily on Stratum, which is GNMI, GNOIP for runtime and things like that, and assume those as a minimum requirement. Basically, these provisionally the answer to the first question is yes, we can assume GNOI is the minimum, and move forward with that. And then as we encounter devices which don't, or that we need to provide support for devices that don't, then we can invest in such adaptation proxy. That would be my suggestion. That way we don't have to dilute our efforts with what if scenarios. Now to your second question, clearly we should be talking with service providers and others. Although I would assume that since GNOI is a Google invention and Google has presumably created it to mirror the needs that they have on their network, I would assume that GNOI would be reasonably adequate for this, at least as a way of interacting with the targets. Clearly, in terms of the API to manage the certificates and things like that, I would assume that we could look at the Kubernetes facade.
I wanted to make a point on the second one, if that's okay. The second question. It's a little bit kind of tangential, but I've seen a system before where there was like a certificate authority, like it was Let's Encrypt or Global Sign, and they give out certificates that in turn can be used for further signing. So, I mean, I think I could see a 3-level system working where, as ONF organization, we get a certificate that, is publicly accepted and publicly validated. We create a certificate authority for all ONOS instances from that. And then, per cluster, we can have a certificate authority as well that can create certificates just for that cluster. But what it means is if you take the GUI and use one of the certificates created from that chain and open it in a browser, it won't give you a warning that this is from an untrusted certificate chain. So I think it's a kind of a tangential point, but I think it's from the outset it's probably one that would be necessary as well, because I think customers might have a similar kind of an infrastructure.
I see.
So just something to bear in mind. I put it in the comments, Adib, of your slides. So just so
yes,
you can
that would be great. Probably you can add a bullet to the open questions that we can.
Yeah, I will.
So if later on we remove the comments, so we assume that those considered. So probably it would be better to add a bullet there.
Right. Do you want me to go ahead and create a repo for this so we can start sketching out these things, or do you want me to hold?
It's totally fine with me. So regarding the architecture, so if we need to discuss more, probably we can do that. So originally I was thinking that I made some changes. Originally I was thinking that probably we can integrate a solution with ONIT, and then at the same time that we deploy the subsystems, we manage the certificates there. But Andrea pointed that in production environment, we want to assume that there is no ONOS subsystem, right?
Exactly.
So then we need a separate subsystem to manage certificate. So yeah, we can do that because cert manager, the Kubernetes cert manager provides an API, so we can use it anywhere. So
Yep. No, I like the architecture because we rely, it provides nice integration with the Kubernetes certificate manager, and we kind of rely it as a background mechanism to and disseminate. And the ONOS certs here is basically just a facade to provide, maybe enhanced interfaces and utilities to be able to interact with it easily. So we've done similar thing with OSGI configuration subsystem and feature subsystem to allow those native mechanisms to do the heavy lifting, and we just provide a nice facade for it to add some value. So I'll go ahead and I'll create the repo because I'll be creating ONOS ops anyway. So I'll create ONOS ops and ONOS certs, and we can start sketching out some of these.
Yep, we can start working on it. Yes.
I think that the first task should actually be internally folded, because at the moment, as to the best of my knowledge, Chatham does not support.
Yes, we can do that actually.
Management.
It's not dependent to that. So when we develop the ONOS certificate subsystem, we can assume that the devices doesn't support that, because at least we need to support the certificate for the subsystem.
Yes, exactly.
So when I said ONOS ops, I did not mean it as related to this at all. I was just going to be creating the repository. I was thinking about it yesterday anyway. So yeah, they're unrelated. Even though they appear on the same diagram.
Good. Any questions, any comments?
No, this is great. Thanks for taking the initiative and looking at this.
You're welcome.
Yeah, looks good. It's good. Thanks, Adim.
Thanks. Okay, so I'm done. If you want to take
I mentioned briefly the docs. You said, but I think I may have gotten mixed up. You said you were going to cover that next time, right? In our
it's up to you. I can cover it some of them because actually I'm still working on it. So it's two phases project in my opinion. Currently, what I did, I automated the managing of the docs. I mean the building process. So we can push the docs automatically to the repo. So using the Travis. So I already handled this, but the next step would be the versioning. So probably I should write a program to handle the versioning. So I was discussing with the team.
So why don't we cover that next time then?
Yeah, so that would be great probably.
Yeah.
And we cover it next time.
Andrea, you were going to say something?
Yeah, I was saying just to be mindful of the time, and since it's not settled yet, I think it's best next time.
Right, yeah, okay.
Yep.
My thought, exactly. So anyway, so thanks again, Adi. So we'll schedule one for 2 weeks from now to cover the doc stuff. Just a brief mention, this is just a reiteration of the email I sent yesterday. ONOS Classic Master and the 2.2 branch are now being built by Bazel 1.0, which is an official release, which means developers will have to make sure that part of the toolchain is installed on their developer machines. So this is I think, big milestone, one of the big items for the ONOS 2.3. Surprisingly, it was actually not too difficult to accomplish, so that was good. We'll still be looking at 1.15 because 1.15 is a long-term support release, so we'll see if we can upgrade it to Bazel 1.0 as well. See whether we can do that independently of the upgrade of the JDK or whether it needs to be done together. What I mean by the upgrade of the JDK is not to the 11, but rather to the open source, or I guess non-Oracle constrained version of the Java 8 JDK. I think it's called Corretto, right?
That's one deployment of it. That's the one that comes from Amazon. There are several others. I think we're actually not using Corretto.
Because
We're
that
using
will
another one.
that will allow the users of ONOS 1X to have a way out of the Oracle jail.
Yes.
So with that, I think we have 7 more minutes left or so. Are there any questions, suggestions, or other topics people want to bring up?
I have one.
All right,
Oh.
Bill has one. All right, speak. Somebody.
Everybody in this meeting is from ONF.
Yeah.
Yes.
Who in the external community outside of ONF do we think should be interested in where we're going with all of this? And I'm just curious, how do we get some additional interest in?
Great question. I would love to know the answer. So
David B usually comes. I don't know why he couldn't come this week. He's pretty good.
we have David, who's clearly on TSC.
Laszlo will pop in occasionally.
But clearly we need more.
Yeah.
I mean, I would love to have more.
So I have a theory.
So, go ahead, Ray. I have mine, but please do.
So my theory is that this will be very quick. My theory is that in the early days of ONOS, it was a open source controller that was doing all sorts of neat things that people understood because they were doing research in SDN. Now we're doing a configuration tool and nobody cares about it other than the providers who assume that it's just going to be there. That's my theory. I don't know. What were you going to say?
I think that partially that is an answer. The other answer is that there's a lot of shifting sands, and it's difficult to get plugged in at the moment because there's really a lot of moving pieces that could get somebody confused on the outside. The other component to this is that I think that people will start to contribute to this when they see something that is somewhat usable for a certain level of devices. And at the moment, really, this is only be tested / worked on with the Stratum.
Right.
So
Yep.
that's really about it.
Yep.
One option to see more people here on the config side would be providing a netconf adapter and showing a demo on top of a netconf device. That's an option. To get more people on the control side, start the control development, and we'll get the P4 community in. So I think it's a result of the state the project is at the moment. That is my take.
At Connect, I was asked about netconf a lot. People are like, Stratum is cool, but I already have gear, and what is this going to do to help me?
Yeah, can I say something?
Sure.
Absolutely.
At least from the research perspective, in my opinion, researchers are still doing research in SDN based on OpenFlow.
Right.
So, and that's one of the reasons that actually we are talking about next generation of SDN, right? And next generation of SDN controller based on a microservice architecture. I think people are still doing the research based on the older stuff. So, and it takes probably a few years, or I don't know, that people migrate from that environment to this new environment. So, yeah, this is my opinion. But I think when ONOS control comes to the picture, project will get more interest from the.
Again, I second what Adib said. I think if we're looking at the research community, the config part is not of interest at all by any means.
Not at all.
So,
And I think that
Just on that point, though, I mean, previously we had a dynamic configuration brigade, and there seems to be a fair bit of interest in that. I mean, isn't there a parallel there?
when you say a fair amount of interest, that was Huawei.
That was driven by Huawei before?
Well, but NEC was interested too, right? NTT.
They dropped.
By proxy NEC. I mean,
NTT was interested, and NTT was interested in that because of the use case, rather not the config in itself. They were interested more in what it can do rather than with our optical topologies and with our non-optical topologies, with our packet topologies, what it can do rather than what it is.
Yeah, I mean, I think there was a kind of an interest previously in having EMS kind of functionality in ONOS, and I think that's where some of the dynamic configuration interest came from, at least for me in Microsemi, and I know Laszlo in Huber Schnuber, they wanted to use it as an element management system as well, and I thought that's where a lot of the interest in config was coming from. So I don't know where that interest has gone. I know in Microsemi it's not there anymore. I was one of the kind of drivers for it. But yeah, NTT, I presume, and Sienna had similar interests.
Yeah, I know it's a $1 million question.
Okay.
I wish I had an answer, or actually, better yet, I wish I had.
$1 million.
So thinking about who will be consumers of this at some point, it seems like people in those communities. I think of the RAN, right? Probably should be somebody related to the RAN in this, but then that may end up being another ONF person. So.
Yeah, I mean, just based on what I talk to people at config on the brain, Connect. The people interested in our demo were non-programmers. They didn't care about Kubernetes. They didn't care about Go. They didn't care about GNMI. They didn't care about any of that stuff. They were like, "Oh, cool! Something that I can use to prevent guys from typing at CLIs." That's how they were thinking about it, because they were all from the provider side. They weren't developers.
That's true. I did talk to several people at Connect that did express interest specifically in coming to TSD meetings, and we haven't seen it.
Okay.
And also, another point is that currently this is not used for any of our solutions,
Right.
meaning that none of our projects, which are where people are putting interest in, is using this. So that to me means that, yet again, as we have seen with the previous version of ONOS, the platform is just a given. As soon as you start building use cases, people will start coming in.
Yeah.
Meaning, let's say we're going to port Trellis on top of this, people are going to start coming in.
Right.
At least that is, again, yet another thing that we should add to the picture.
Like a ZTP kind of fully fleshed out solution